So to construct a copy of a line segment, the main thing it needs to have is the same length. That's the main thing that we're looking for. So the first thing is, we'll go through a couple vocab terms. Coplanar means that they're just in the same plane. So if you want to underline or highlight or a couple of these vocab terms, planes that are in the same plane are coplanar. So same plane, coplanar. So it's technically points that are in the same plane, but if you just see the word coplanar and think same plane, you'll be good. So collinear, root word there is line. Same line, collinear. And then lines that are in the same plane but do not intersect or parallel. You probably already know that vocab term, but lines in the same plane that do not intersect are parallel. And then a postulate is kind of a building block for geometry and math, really, in general. It is a statement that's accepted true without proof. So it's you can just say it, people agree it's true, and they don't need to have you prove it. Accepted as true without proof. So we're going to start with doing some constructions. Now the segment addition postulate, now remember this is accepted to be true without proof. If you just look at this, it's because it makes sense. It's kind of like a duh statement. So if B is between A and C, so here's B between A and C, and they're all collinear, then AB plus BC equals AC. If you add up the two parts, you get the whole thing. Duh. That's why it's a postulate. You don't need me to sit here and go through a page and a half for explaining it. It's true because it's obvious. So that's called a postulate. So in geometry, we're going to basically start with that and talk about a construction, which is an accurate representation with no numbers or measures. So we're not actually using a ruler or protractor or anything like that. We're only going to use a compass and straight edge. How we're going to do that. So first we're going to use a straight edge to draw a long line segment. So for me on here, I don't need a actual tool that's a straight edge. This will automatically do a straight line for me. You would just use a ruler or anything straight, like the straight part of your protractor, a ruler, the side of your ID card, whatever. Anything that is straight, you can make a straight line with. Label an endpoint X. And then to copy a segment onto there, you will put the point of your compass on A, and then stretch it so that the pencil reaches over to B. And then you can pick up that compass and it'll save that distance as long as you don't bump it. So then we're going to mark off that same length over here, starting at X, placing the point on X, and then we'll use the pencil to make a little arc. And we will label that point Y. So now this length XY is the exact same length as AB. there's AB, there's XY, the exact same length. Now we're going to copy CD and just kind of pick it up where we left off. So now we're going to stretch our compass from C to D. Then we're going to move the point of the compass to point Y and make another little mark there, an arc. And that is just to label that point Z. So what we just did was that segment addition postulate, which says this entire length of XZ is equal to the sum of the two shorter lengths added together. So it's AB plus CD, because this had the same length as AB, this had the same length as CD. So now XZ is the length of the sum added together. All right, so the first thing we need when we're copying these two segments, we're going to make a longer line segment first. Label one of the endpoints X. Then we're going to grab our compass. Put the point on A first, and then we'll stretch it all the way out to B. And now we've got that length saved. We just have to take it and copy it up to the top. Now it says label that point Y. And we'll do the same thing with the other segment, CB. So put the point on C, pencil on D. And we're just going to add that on to where we just ended on the longer segment. So point on Y, mark it off, and we'll label that new endpoint Z. So now XZ is the sum of the other two segments. So now we'll talk about the distance formula. You may have seen this in other math classes already. But when you have 2 points, you can find the distance between those points just by plugging in the x coordinates and the y coordinates. You need to subtract x minus x and square it, and then y minus y, square it. You'll add those two answers together and then take the square root. If you have it drawn out like this, you can also see, now maybe you've heard of the Pythagorean Theorem, where you have a squared plus b squared equals c squared. The way that you get these two lengths, when you take the x coordinate minus the x coordinate, that will be b. So I kind of labeled it backwards, but and then the y coordinate minus the other y coordinate, that would be a. So it's really the same thing as Pythagorean Theorem. You could always, if you have them drawn out, you could make it a right triangle and do Pythagorean Theorem. There's nothing wrong with that. All right, so AB and CD, we're going to find the lengths of those and see if they have the same length. So AB, you got to identify the coordinates first. So it's at -4, +4. And point B is at 1, 2. And we've got point C, 2, 3. And then point D is at 4 to the right and down 2. So that's 4, -2. So when you're doing the distance formula, it's a big square root. You do x minus x, x2 minus x1. So that's 1 minus -4. and you square it. And that's y2 minus y1, so that's 2 minus 4 squared. So 1 minus negative 4, that's 5 squared. And then 2 minus 4 is negative 2 squared. So that's 25 plus negative 2 squared is 4, positive 4. So that's the square root of 29 when you add it up. And then from C to D, same idea. You take the x's and subtract them. So 4 minus 2 squared. And then the y's, negative 2 minus 3 squared. So that's 4 plus negative 5 squared is 25. Which is 29. So do they have the same length? Yes. They have the same length. They're both square root of 29. We'll do pretty much the same thing for EF and GH. So for EF, we need the endpoints. Negative 3, 2. F is at negative 2, negative 3. G is at negative 2, negative 4. And H is at 2, 0. So then we will use those points in the distance formula. So it's x minus x. So x minus x, negative 2 minus 3, or minus negative 3. And then y minus y, so that's negative 3 minus 2. So minus and negative, that's plus. Negative 2 plus 3 is 1 squared. That's negative 5 squared. So that's 1 plus 25, which is square root of 26. So x minus x, 2 minus negative 2. And we take the y coordinate, 0, minus the other y coordinate, negative 4. Minus negative is plus, so that's 4 squared. And minus and negative is plus, so that's 4 squared. So 16 plus 16, that's 32. They're not the same. Square root of 26 is not the same as square root of 32, so no, these are not the same length.